Hi guys, welcome to Learn Tech from Zero. Today we'll be covering further CCNA topic. So let's begin with today's topic, which is spine leaf networking architecture. So what is a spine leaf topology? The spine leaf topology is a modern network design mostly used in data centers to provide high-speed connectivity, low latency, and scalability. So what it means is this technology, this architecture, sorry, not technology, this architecture, this design is mostly used in data centers. So data centers are like just big area, like a big buildings or a private area where you have like thousands, hundreds and thousands of powerful computers, servers, and what they do is they provide high speed connectivity because they are very powerful, and there are many of them, and they communicate with each other. They can give you high speed connection, low latency, because they are right next to each other, so they don't have to travel long distances. So you have this like very quick delivery of data and receiving of data. And scalability means you can easily add, remove um, networking devices. So the basic structure in spine leaf networking architecture, the structure is you only have two layers, unlike two-tier and three-tier networking architecture that we have already covered. So if you have missed out, make sure to watch other videos. So in spine leaf networking architectures, which is only used in data centers, it only has two main layers, which is leaf layer and spine layer. I'll just quickly show you. So they are usually just layer 3 devices. So layer 3 switches. If you don't know what layer 3 switches is, you need to watch our other videos. So this is spine leaf layer. Sorry, this is the spine layer and this is the leaf layer. And all the devices, they normally connect to the leaf switch, which is usually a layer 3 switch. And so you can see that in the first layer, which is the leaf layer, which is for accessing um, the internet or the communication hub. So what happens is you can see there is a router connected to this switch, there is a server connected to this switch, and you can see that in another one there is a computer connected to this switch, and there is a firewall connected to this switch. And in this networking architecture, how this works is leaf, those layer 3 switches that the end devices connect to, they are never connected with each other. So they normally connect to another layer 3 device, layer 3 switch, which is called the spine layer. And then what happens is all the leaf switches are connected to all the spine switches. And leaf switches, they don't connect with each other. Spine switches, they don't connect with each other. And all leaf switches connect with all the spine switches. So you can see that. Let me explain it for you so that it makes sense. You can see that this leaf switch, which the router is connected to, you can see that this one is connected to this layer, this spine layer 3 switch, which is the core layer. This is where all the thinking happens, where all the configurations are made in the spine layer. Okay, so you can see that this switch is connected to this spine, and this spine. You can see that 1, 2, 3. And the same goes for the other switch as well. It is connected to all the spine. You can see right there, and then right there. The same goes for the other two leaf switches. So what happens is, because of this design, it's very easy. So when we say low latency, what happens is very easy to communicate with each other. So if let's say a computer access, this computer wants to access resources from this server, what happens is it goes to this spine, all right, this layer 3 switch, and then this one provides basically directs the traffic to this switch, and then it goes to the server. So it's, with this design, it's very easy to communicate with each other, and it's really fast compared to two-tier and three-tier architecture. So you can see that again. Let me just break it down for you. Let's say this area wants to communicate with this area. You can see that it will go from there to the leaf switch, and it goes to the spine, and then spine is already connected to this leaf switch, and then it can just, you know, communicate with each other very quickly. So it's literally the same number of hops. When we say hops, like how many devices it has to go through to communicate with each other. So with spine leaf architecture, it's always 2 hops. So you can see that when it's communicating, so it goes from 1 hop, 2 hop. The same way, if you want to communicate this one to this one, it goes from 1 hop, 2 hop, and then it gets delivered. If this wants to communicate with this one, it goes 1 hop, 2 hop. So that's why it has the same number of hops. So it has the same. There is a term called ECMP, which we will cover later on. So you don't need to know. So equal cost multipath. So it costs the same. So it's literally for communicating with each other. It could have different paths. It depends on how many leaf switches and how many spine switches are connected, but it's always the same number of hubs, and it's very quick and very fast and efficient to communicate with each other. And I will just explain it to you again. Leaf switches, they don't connect with each other. Spine switches, they don't connect with each other. But all leaf switches are connected to all spine switches. That's it. All right, let's just begin with some of the explanation. So the leaf switches are the access layer that connect to servers. So as I have already mentioned, leaf switches are the access layer devices. So all the end devices, they connect to these leaf switches. So all these, in the data center, all these devices, right? They are connected to the leaf switches. All right, and then so server, storage, firewalls, load balancers, access points. These are all physical devices. They're all connected to the leaf layer. So the leaf switches. The spine switches acts like the core layer in the traditional network. So the core, when we say core, this is where they do all the thinking, all the routing, and security, ACLs, so etc. You don't want to go too much in details. So the spine layer is basically the core layer where all the thinking happens. They interconnect all the leaf switches. They're all connected to all the leaf switches available. All right. Key characteristics. Just go through those key characteristics, and if you have any questions, just leave a comment. So how traffic flows. So the traffic goes from the first leaf switch up to the spine switch. That spine switch then sends it down to the destination. This is what I've already explained to you. How communication works is it goes from here to here, and then from there to there. It's literally the same. So if they want to communicate with each other, it goes from the leaf layer to the spine, and then spine to leaf, leaf to spine, spine to leaf, leaf to spine, spine to leaf. All right, and then the scalability and expansion. So one of the main benefits of this design is to add more servers. Just add a new leaf switch, and also connect it all to the spine switch. So if you want to, let's say you have more devices, now let's say this switch is not enough to connect more devices, you can literally add another leaf switch, and you can connect that to all spine switches, and that's it, it's all ready. So it's very easy to scale, to basically expand the network. All right. And because of this scalability, this is because of the design, and because of the ECMP. So what happens is it's the communication between the devices are very fast and efficient. And also they those devices, mostly in data centers, this is not the actual data center um, end devices, but in data centers, they, or most of the, it's basically they have very powerful server computers, like server PCs. So because they are already very powerful, they can communicate with each other with this design even more quickly. All right. Benefits: high performance, low latency, resilient, easy to grow, content design. Go through them. If you have any questions, just leave a comment. And for the exam, you don't need to know too much in details for spine leaf architecture, two-tier architecture, three-tier architecture. You just need to know how they work in general, and what are the devices in each layer. So in spine leaf architecture, this is just layer 3 device, layer 3 device. So these are all layer 3 switches, layer 3 switches. Okay. Now I think that's enough for now, and you also need to know the key terms to remember. So make sure that you study these. And east-west traffic and north-south traffic means, so spine leaf architecture is mainly for east to west traffic. So east west traffic is when devices communicate with each other, like different servers are communicating with each other. Let's say a virtual machine is communicating with a server, a firewall is communicating with a router, etc. So east west traffic is when devices communicate with each other. So data centers are mostly east west traffic. So for that, this spine leaf architecture is really good and it's really fast, because it can just communicate with each other using the same number of hops, which is just 1 2 1 2 1 2, like that. And it's very quick and fast. And north south traffic is, it doesn't apply here. North south traffic is when users communicate with the internet directly. So this is mostly for LAN design. So basically the two-tier and three-tier networking architectures use north south traffic. That's it. All right, let's just try a few multiple choice questions, and we'll finish it after that. So if you have any questions, leave a comment and I will make sure that I get back to you. And if you are new to our channel, we provide free education and free training. So if you have any questions or if you need any help, just leave a comment and we will be happy to help you. All right, let's start with the quiz. So we'll just try, let's say, 3 or 4 questions. So what are the two main layers in the spine leaf topology? So it's very simple. It's called spine. The answer is right there: spine and leaf. Axis and distribution, core and axis. These are in 2 and 3 tier. And aggregation and edge is a different case. So spine and leaf. That's the answer. Let's try the next one. In a spine leaf architecture, what is the main role of a leaf switches? So these are leaf switches. So normally the end devices connect to those leaf switches. So to interconnect all spine switches, no, that's not their job. To connect end devices such as servers and storage, yes, that's the correct answer. To route traffic between spines, no, they don't do any routing. It's what the spine switch does. So we are talking about leaf. To act as a backup for spines, no. So the answer is the end devices connect. Yes, correct. All right, now the third one. In a spine leaf topology, how are leaf switches connected? So each leaf connects to every other leaf? No, they never connect with each other. Each leaf connects only to one spine? No, each leaf connects to every spine. This one is connected to this one, this one is connected to this one, this one is connected to this one. So all these leaf switches, they are all connected to all spine switches. So not one, each leaf connects to all spine. So no. Each leaf connects to all spine switches. Yes. Each leaf connects to the core router only. No. So we'll just go to each leaf connects to this one. Correct. All right, let's just try one more. Which type of traffic is optimized in spine leaf data center architecture? Northbound, north-south traffic is when users communicate to the internet. So this is for two-tier and three-tier. You need to remember that. Broadcast traffic and multicast traffic. This is something to do with routers and switches. So don't worry about that. We are talking about the architecture. So in that case, it's east-west. So you need to remember east-west. East-west means when devices communicate with each other. North-south means when you communicate with the internet. So the answer is the traffic is optimized in spine-leaf data center architecture. What kind of traffic? So mainly this is designed for communication between different devices. So the answer should be east-west. Okay, so that's it. I'm not going to go any further. If you want to try all these quiz, just go to learntechfromzero.com and you should be able to do that yourself. So thank you for your time and I will see you soon.